All right, welcome to today's today's lesson. So today we're going to be sketching the graphs of exponential functions. Yeah, so we're going to be sketching the graphs of exponential functions. Okay. So today's lesson is not going to be very long because we're only going to revise what we did last time. We made just 2 questions from what we did, and then we proceed with the exponential functions. So yeah, so this is the revision I'm talking about. Write each of the following in logarithmic form. So when you're writing any given expression in logarithmic form, what you need to know is this is always the index. So when you look at this expression here, this is in exponential form. Now you need to convert it. It has to look like this. Yeah. So this one, from what we discussed, this 10 is always called the base. And then the index is this one. Oh, sorry, the time I said this one is the index, I made a mistake. This 6 is the one that is the index. So this one, this 10 is the base. Then there, this x plus 1, that's the index. Yeah. So for us to write this in exponential form, we need to do this. You always start with the index. You write your index, x plus 1. You write it like that, and then you say equals. And then you're going to say log y base what? Base 10. So in most cases, when the logarithm is in base 10, you don't normally show the 10. You just leave it like that. So those are just some of the rules of logarithms. So you can just leave it like that. There's no problem. But in this case, since I want to show you one important rule again, I'm going to write it like that. So you can also now write it like this. You take this one to the other side of the equal sign, it becomes -1. Then you say plus log y base 10. So let me show you another rule or another way of converting that to logarithm. So first of all, you have to note to say, when we say log 5 base 2, this can also be written as log 5 over log 2. It's just the same. So when you punch on the calculator, you write this on the calculator, you still find the same answer as a person who wrote this. The person who writes on the calculator log 5 base 2 and gets the answer, it gives him the same answer as the person who writes log 5 divided by log 2. So the other method I wanted to show you is that if you have such an expression, you just introduce the logs on both sides. So we have log 10, and then we have x plus 1, and then you say equals log y. You introduce the logs on both sides of the equal sign. So once you introduce the logs, you can drop the power. I'm sure we know, or we have an idea of how this power goes down this side. So you drop the power this side. So we drop the x plus 1 this side in brackets, and then we are remaining with log 10 here. Then this is equal to log y. And then you divide both sides by log. Okay, let me just do this. Yeah, log 10. Even this side you divide by log 10. So you can see that that log 10 and that log 10 will cancel, just remain with x plus 1 this side being equal to, so log y over log 10 can also be written as just log y base 10. Yeah, from this expression this side you can write it in that way, and then you take the x to the other side of the equal sign. I mean, you take the 1 to the other side of the equal sign, you have something like this. Okay, log y, and then since it's in base 10 you cannot write it if you want. So now instead of you maybe spending the whole time spending a lot of time doing this, it's just important that you know to say, when you have been given this expression, the 10 here, which is the base, will always be the base even when you convert it to log. All right, so now let us look at how you can convert the log 64 base 2 is equal to 6. How you can convert that to exponential form. All right, so I'll not delete this. Let me just demarcate. So to convert this, we know to say this 6 will always be the power, and then this 2 is the base, and then this 64 will stand in the place of y. So this 2 is the base, so I can write the 2 as the base. And then this 6 is the power, so I'm writing the power there. And then I'll say equals 64. Even, the question is even done. This is the solution. You can try to prove it on a calculator again. You find to say the when you raise 2 to the power 6, the answer will be 64. Right, to proceed. So the other thing that I said we're going to look at is sketching the graphs of exponential functions. And then after this, there's also an exercise at the end, which you'll be required to answer. Please make sure that you do what you submit this exercise. So sketch the graph of each of the following functions. F of x is equal to 3x. We have f of x being equal to 2x minus 1. And then we have f of x is equal to 2 plus 3 to the power x. Then we have the f of x being equal to negative 1 plus e to the power x. So these questions are very simple and straightforward. And I'm going to show you how you solve each of these questions. So to start with, let me start with this question. Okay. So first of all, you need to identify your horizontal asymptote. So the horizontal asymptote, according to this question, is just the x-axis. It may have been a certain number if we had something this side. If it was maybe plus 2, would have said the horizontal asymptote is y is equal to 2. Now in this case, we don't have any number. It's 0. We only have a 0 this side, because this one can also be written as plus 0. So meaning our horizontal asymptote, it's very important to first find the horizontal asymptote. So the horizontal asymptote is nothing but y being equal to 0. So so the line where y is equal to 0 is just the x-axis. Okay. So now what we do is we now draw the the table of values that is going to help us to sketch. So we put our x and our y that side. Let us try to find two numbers that we can, there's two numbers, simple numbers, not very big numbers, simple and small numbers that we're going to use to sketch. The numbers that will just help us to know the direction, how the curve is going to move. So we are going to say, okay, let's try to put 0 there. When you put 0 where there is x, you put 0 where there is x, means that 3 raised to power 0 will get 1. When we put 1 there, 3 raised to power 1 will get the same 3. So when it comes to sketching, we're going to have something like this. Okay, we write our 0 there. Then you have 1, we have 1, 2, 3, we have 1, 2, 3. Okay, we have 1, 2, 3, 1, 2, 3. So these are negative numbers, negative 2, negative 1, 1, we have 2, we have 3. We have 3, 2, 1. We have 1, we have 2, we have 3. Okay. Now let us try to sketch. So when we are sketching now, let me just write this 0 properly because some of you might get confused. So when we're sketching, we put in these values. We said our horizontal asymptote is y is equal to 0. So the line which is y is equal to 0 is this line here, which is just the x axis. And then, so what we do is we now do what? We now plug in these values 0, 1. 0, 1, we have our first point there, 0, 1. Then we have 1, 3. We have 1, 3, meaning we have that other point there. So horizontal asymptote is the x-axis. So this is just, we know what an asymptote is. We learned in calculus. An asymptote is simply just a number, a line that no matter how you can, I don't know what word I can use, but no matter how you can draw the sketch, I mean the curve, that curve will never touch its asymptote, but it will, as it is going, the more it goes, the more it elongates, it gets closer to the asymptote, but it will never touch the asymptote. That's the way it is. So this is how it's going to be. And that is the sketch. You can even say this one is f of x being equal to 3 to the power x. And now here we also have to find the domain and the range. So the domain, we can see that we can plug in any real number there. You still have your answer. And then the range, so the range there, to find the range will always start from the horizontal asymptote up to infinity. That is the range. Okay. All right, so this is how simple these questions are. They are not complicated, they are simple. All right, so we proceed. Let's move on to the next question, which is this one here. Okay, let me just switch off my WhatsApp, it's making noise, I guess. All right, so we proceed. We move on to the next question, B. So B is saying f of x is equal to 2 raised to power x minus 1. So that question you also solve it the same way we solved the previous question. You first draw, or I mean first you identify your horizontal asymptote. So the horizontal asymptote is simply y is equal to, so the horizontal asymptote is just y is equal to 0 as well. We don't have anything this side. The only questions that have horizontal asymptotes are this one and that one. Even these have, but their horizontal asymptotes are zeros, so they're just important to show them as well. And we now find the table of values. This is x, and then that is y. So find numbers that when we put there, at least they will not give us a very big number. So we can put +1 so that when you subtract 1 minus 1 there, so when you put +1. So if you put +1 while there's x, 1 minus 1, you get 0. Yeah, sorry for that network interruption. So, and then we do what? We also find another number. We can put 2 there. 2 minus 1, we can put 2. So 2 minus 1 is 1. 2 raised to power 2, you get the same. Oh, sorry, 2 raised to power 1, you get 2. All right. So we do a quick sketch. Okay. We have 1, 2, we have 1, 2. Then we have 1, 2, like that. 2, 1, 1, 2. So you have 1, 1, which is there. We also have 2, 2, which is there. Then the horizontal asymptote is just the x-axis here. So meaning you draw your curve like that. Okay. So even here you find the domain. The domain, we said it can be any number. So you can plug in any number from -infinity to infinity. But the range will always start from the horizontal asymptote up to infinity. All right. So these questions are very simple and straightforward. So to proceed, we move on to this question here. So the horizontal asymptote in this question is nothing but y is equal to 2. You just get this number there. Y is equal to 2. And then what you do is you draw the table of values. You draw the table of values there. Okay. And then begin to plug in values. We find numbers that we can put there, which will not give us very big numbers. So when we put a 0 there, 3 raised to power 0, it's 1. 2 plus 1, so when you put 0 there, 2 plus 1 there, it gives you 3. And then when you put 1 there, 3 raised to power 1, you get 3. 3 plus 2, you get 5. So when you put 1 there, you get 5. So from there, we now do the sketching. Okay. The sketching. So we have on our positives there, we have 1. Sorry, let me just write at least. Yeah, so we have 1, we have 2. Then here we have 1, 2, 3, 4, 5. Of 1, 2, 3, 4, sorry for writing the big 4, then we have 5. Then from there, we can now start plugging in the values. Let me also put 6. So we have 0, 3, 0, 3, we have 1 point there. Then we also have 1, we have 1, 5, which is just this point there. But remember, the horizontal asymptote is y is equal to 2, meaning this is the line which passes at 2 like that. Y is equal to 2. So meaning our curve will not touch the horizontal asymptote, hence it's going to come out like this. Okay, wow. Yeah, so it's going to come out like that. So this is the sketch. So these questions are very simple and straightforward. You don't need to stress when sketching this. You find the domain. The domain, you can plug in any positive, any negative or positive real number there. You still have your answer. So the domain is just any number, and then the range, you always start from the horizontal asymptote going to the positive infinity, because our curve is going to the positive infinity. If it was going like this, we would have written our range as negative infinity to 2. That is how it would have been. So we proceed. So that is the solution for the question C there. All right, let us now look at the last question, which is D. So D says the function f of x is equal to -1 plus e to the power x. So that one, this question is also very simple. Yeah, it's also very simple. First of all, you also have to identify the horizontal asymptote. The horizontal asymptote, which is just y, is equal to this number here, which is -1. So y is equal to -1 is our horizontal asymptote. Okay. Then we now draw the table of values, which is we put the x values there and then the y values this side. So when we put a 0 here, when we put a 0 where there's x, we're going to have e to the power x. So e to the power x will give us 1. Oh, sorry, when e to the power 0, when you put a 0 there where there's x, e to the power 0 give us 1. So -1 plus 1 will still get a 0. So now this e is a number. We know to say this e is a number. Yeah, and then this number is simply it's just something that is about, is it 2.718 going up like that, 2.718 going up. But us here, since we're just sketching, we're not drawing. You know, there's a difference between drawing and sketching a curve. If they tell you to sketch a curve and to draw a curve, they mean different things. Sketching, you use just approximate values, but drawing, you make sure that the curve comes out very accurate. Yeah, meaning you have to take into consideration all the measurements and everything. So here we're going to assume to say this e is just equal to 2.7. So I'll just assume to say my e is just equal to 2.7 for me to sketch the curve well. So what I'm going to do here is I'll replace, let me try to find another number which I can put there. Maybe for instance, if I put 1, e to the power 1, I'll still get the same 2.7, which is equal to e. And then so -1 plus 2.7, I said if I put 1 there, Negative 1 plus 2.7, I'm going to get negative 1 plus 2.7, I'm going to get 1.7. So I can now do the sketching here. Okay. There's a 0 there. Then we have 1 there. We have 1, 2, 3. So we have 3, 2, 1. Then we also have our horizontal asymptote there. She is negative 1. That is our horizontal asymptote. And then we plug in the values now. We plot the values. 0, 0 is just there. And then we have 1, 1.7. 1, 1.7 can be somewhere there. So now this is how the sketch is going to come out. Like this is how it's going to be drawn. This is how it's going to be sketched. So now we find the domain and the range. So the domain is just simply the same thing from negative infinity to positive infinity. And then we have the range. You start from the horizontal asymptote going to the positive, positive integers. Yeah. So this is all that you need to know about sketching. This is all you need to know about sketching. I know some of you maybe are asking yourselves to say, how or when does the curve come out like that? The curve can only come out going down if maybe, okay, not maybe, but always. If here, maybe if this was not a plus, this was a minus, there's a probability, there's a possibility that the curve can come out going down, can come out like this. Even here, if there wasn't a positive, if there was a negative there, it would have gone down instead of going up. Yeah. So thank you very much for watching. There's an exercise at the end of the lecture here. Make sure that you solve it, you draw, you sketch the curves, and then I'll mark you. Submit before Monday. Okay, thank you very much for watching today's lecture. If you have any questions from what we have been learning, you are free to ask. Okay, so it seems there are no questions. Please, those that have not subscribed to this channel where I post the lecture videos, please do so as early as possible, because when your lecturer begins to release the tutorial sheets, I'm going to be solving all the questions in the tutorial sheets, and then I'm going to be posting them on the YouTube channel. So there may be a chance that I'm not going to be posting them in the group, maybe. Yeah, due to some time, because yeah, due to some reasons. Yeah, so just make sure that you subscribe so that whatever that I'm going to be posting on the channel, it will bring a notification to you. You will know to say I've posted a video, I've posted a question in tutorial sheet. What if I've solved a question, I always name it according to the tutorial sheet. So I'll say, for instance, if I solve question 5 from tutorial sheet 5, or question 5 from tutorial sheet 3, I'll write to say question 5 tutorial sheet 3. So meaning if you have subscribed to the channel, you receive a notification to say you have you receive a notification to say University Mathematics has posted a video which is tutorial sheet 5 question 5, and you'll be there. It will be easier for you to access the video. But if you've not subscribed, you'll be missing a lot. You'll be missing certain things that I'm going to be posting there. All right, thank you very much for watching. See you on Monday in the next lecture that we're going to have, and we're going to do simplification and solving of logarithmic functions Yeah, and then we even call it the end of logs. And then Tuesday, maybe we might start mathematical induction. After mathematical induction, we'll go into what's this? Uh, Partial fractions. After partial fractions, I don't know if Mr. Martin is going to allow to go further than partial fractions. So if we are going to finish first, maybe we would even start just going through tutorial sheets to revise questions. All right, thank you very much. See you on Monday.